Welcome all guys to Think Global Education Services SAT math class. Now today we're going to be doing a very small topic, that is trigonometry. Now it's a very basic topic in your SAT. There are only three basic concepts that you need to test. Okay, so we'll be discussing only those three basic concepts. You might have done trigonometry to a higher extent, but we really don't need it there. So let's start with the very basic first aspect of trigonometry. Now they ask you the conversion of degree measure into radians and radian measure into degrees. Now there is a very basic conversion that you need to understand, that 360 degrees is actually equal to 2 pi radian. That's the basic unit conversion. Now using that unit conversion, you can actually figure out any degree measure into radians or any radian measures into degree. Now guys, we can always use the calculator for this. The calculator is allowed in your SAT, but if the question comes in the no calculator section, then you have to convert this manually. So let's quickly take one example and try to understand how do we actually convert radians into degrees and degrees into radian. So let's say, suppose I want to figure out that 90 degree is equivalent to how many radians. So let's use this basic conversion and we'll say that 360 degrees is actually equal to 2 pi radian. So 1 degree will come out to be 2 pi over 360 degree, and hence 90 degrees will be equal to 2 pi over 360 multiplied with 90 degree. So when you solve it, 0 goes with 0, 9 goes with 36 4 times, 2 goes 2 times with 4. So eventually I'll get this as pi by 2. So I know that 90 degree is actually equivalent to pi by 2. So I converted 90 degrees into radians, that's pi by 2. Similarly, let's try to take one example and convert the radian measure into degree measure. Let's say I want to know that pi is how many degrees. So I'll just quickly say that I know that 2 pi is actually 360 degrees. So 1 unit, taking the basic unitary method, 1 unit will always be 360 over 2 pi. And I want to know pi, so I'll just multiply 360 over 2 pi with pi and I'll get the degree measure. So pi will cancel out. 360 by 2 is 180 degrees. So from here I come to know that pi is 180 degrees, and similarly 90 degree is pi by 2. So I can convert any degree into radian or any radian into degree by using the basic unitary method. So I hope this is clear to everyone. Now let's try one question on how they will actually test you on conversion of degrees to radians or vice versa. So let's try this question. So here this question has actually little bit coordinate mixed with it. So we need to understand a little bit of coordinate also to crack this question. Now it says that point A has coordinate of -1, 1, point B has a coordinate of 0, 0, and point C has a coordinate of 2, 0. Find the value of angle ABC in radians. So before we start, let's quickly draw the coordinate, x-axis and the y-axis. So this is x-axis, this is y-axis. Now if I draw the points, just doing a rough sketch, so let's say coordinate A where x is -1 and y is 1. So that point will be somewhere here. So this is point A, which has a coordinate of -1, 1. Then coordinate B is at origin. So this is coordinate B where the coordinates are 0, 0. Then we have point C, which has a coordinate of 2, 0. That means X is 2 somewhere here and Y is 0. So that's coordinate C, which has a coordinate of 2, 0. So I've figured out all the 3 points. They're asking me find the value of angle ABC in radians. So that is very important, guys. You have to read this very carefully. So first of all, I have to figure out the value of angle ABC, and then I'll convert it into radians. If I quickly join this point ABC, I'll get a triangle, as you can see. Now they're asking me the angle ABC. Now if you see, the angle ABC is made up of two angles. One is this, so this basic angle, which is the angle of the axis, and then this remaining angle. So these two add up and make ABC. Now, as I clearly know, the axis will always make an angle of 90 degrees. So this is always 90 degrees. And if I know a little bit coordinate, I will realize that this line AB is actually a reference line which is called y is equal to minus x. As I can see, the magnitude of the points are equal and passing through origin. So this line is a reference line, will exactly bisect the second and the fourth quadrant and actually pass at an angle of 45 degrees. So this is the basic information that I should have of coordinate. Now, if I take the sum, angle ABC will come out to be 90 degrees plus 45 degrees. That's actually 135 degrees. So I got the angles in degree, but be careful. The question is not asking me the angles in degree. The question is asking me the angles in radians. So I have to convert this 135 degrees into radian. And as we learned before, we can directly do it because we know the conversion unit. 360 degrees is always equal to 2 pi radian. So 1 degree will always be equal to 2 pi over 360. That's a very basic unit. Now, if I want for 135 degrees, I'll take 2 pi over 360 degrees and multiply it with 135 degrees and I'll get the value. So if I try to solve this, this will go with 5 27 times, and this will go with 5 72 times. Again, I can further cancel it with 9. It will go 3 times, go 8 times. So I'll get 2 pi into 3 over 8. 2 cancels 8 4 times. So eventually I'll get 3 pi over 4. So 135 degrees is actually equal to 3 pi by 4 radians. So we did it in the same way, the way we did before, by basic unitary method. Now, guys, it's very rare that they will directly ask you that, if I give you an angle in degree, just give me in radians, or if I give you radians, give me in degrees. So they'll try to put a question like this. So here you have to identify the angle first. I've identified the angle and then I've quickly converted it to basic unitary method. So I hope this question is clear. Now, this is the first aspect. We just learned degrees into radians and radians into degree. Now let's move forward and let's try the next aspect of trigonometry. Okay. Now here, guys, we need to understand the very basic idea behind the sine and the cosine. So let me draw a right angle triangle for this so that we can understand what is happening here. So let's say this is the right angle triangle. This is point A, this is point B, this is point C. This is 90 degree. And let's say this angle is theta. Now, if I try to take the sine and cosine according to this angle theta, I should know few fact that sine theta is actually equal to perpendicular over hypotenuse. That's sine theta. And in this particular case, According to this theta, perpendicular is the side in front of it, which is AB, and hypotenuse is AC. Similarly, if I go for cos theta is base over hypotenuse. So here I know the base according to this angle theta is nothing but BC, and the hypotenuse is AC. So we get sine theta and cos theta. That's perpendicular over hypotenuse, and cos theta base over hypotenuse. Now the point that you need to understand here is, let's say this angle C is theta, this B is 90. So if I try to figure out angle A, I know the sum of all the three angles in a triangle is 180 degree. So if I try to add all the three angles, angle A plus angle B plus angle C has to be 180 degree. Angle A I need to figure out. Angle B is already 90 degree, and angle C I have assumed theta. So from here we'll get angle A as 90 minus theta. So this angle A actually comes out to be 90 minus theta. Now guys, this theta and 90 minus theta are called complementary angles. They are complementary to each other. One angle is theta, the other angle is 90 minus theta. So they are called complementary angles. Now, one point that you need to understand. So let's try to derive this. If I try to figure out sine 90 minus theta, that means I'm trying to figure out sine according to angle A, which is 90 minus theta. I know that sine theta is always perpendicular over hypotenuse. According to 90 minus theta, the perpendicular is the side in front of it, which is BC, over hypotenuse is still AC. And similarly, if I try to go for cos 90 minus theta, that means if I try to figure out the cosine of angle A, I will realize that according to this angle, the base is AB and the hypotenuse is AC. So if I see this clearly, I will realize that sine theta is AB over AC, which is actually equal to cos 90 minus theta, which is also AB over AC. And cos theta, which is BC over AC, is also equal to sine 90 minus theta. So from here, we can derive that sine theta is actually equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. So from here, I can make a statement that sine and cosine of complementary angles are equal. If I say sine theta, that will be exactly equal to cos 90 minus theta, and vice versa. So the point that we learned from here is that the sine and cosine of complementary angles are equal. So keeping this in mind, let's try to do a question so that we understand how do we figure out the complementary angles, the sines and cosines of complementary angles. So let's take a particular question. Let's take a particular question to understand that. So I'll draw that question personally. Let's say there is a triangle, something like this, where it's PQR. So let's say this is P, this is Q, this is R. And if I draw this perpendicular, let's say this angle is also 90 degrees, this is also 90 degrees, and this big angle P is also 90 degrees. Now I have already mentioned, let's say PQR, this is S. So QS is given to me 3 and PS is given to me 4. QS is given to me 3 and PS is given to me 4. Now, if I ask you, what will be sine of Q, cos of Q, sine of r and cos of r. So I need to figure out all the four values: sine of q, cos of q, sine of r, and cos of r. So if I try solving this question, sine of q and cos of q are pretty easy because I know the values in the triangle here. Base is 3, perpendicular is 4, so I can figure out the hypotenuse by using the Pythagoras theorem. So in triangle PQS, if I apply the Pythagoras theorem, I know that the hypotenuse square is equal to perpendicular square plus base square. So PS is already given to me 4, so 4 square, QS is given to me 3, 3 square, 16 plus 9, 25. So from here we get the value of PQ as 5, which is under root of 25. So I know the value of PQ is 5. So similarly, if I know the values in this triangle PQS, in triangle PQS, I can directly figure out sine Q. If I take this angle, sine Q, sine is always perpendicular over hypotenuse. According to this angle Q, perpendicular is 4 and the hypotenuse is 5. So sine Q will definitely be 4 by 5. Similarly, if I go for cos of Q, according to this angle Q, cos is always base over hypotenuse. So according to this angle Q, the base is 3 and the hypotenuse is 5. Now this was an easy part. We have to figure out, so I got the value of sine Q, which is 4 by 5. I got the value of cos Q, which is 3 by 5. Now if I really want to figure out sine and cosine of angle R, now do you realize this angle R is nothing but the complementary angle of Q? Since if let's say this is theta, the big one is already 90. So angle R automatically becomes 90 minus theta. And from the previous uh, slide, we just know that the sine and the cosine of complementary angles are equal. So from here, I can directly say that sine Q is actually equal to cos of R and cos of Q is actually equal to sine of R, because I know that sine theta is always equal to cos 90 minus theta, and cos theta is always equal to sine 90 minus theta. So from here I can directly say that sine R is nothing but actually equal to cos of Q. So sine R will also be 3 by 5 and cos of R is nothing but equal to sine of Q, which is 4 by 5. So I need to know the fact that the sine and cosine of complementary angles are equal. So if you know that, these questions would become easy, and if I know sine Q and cos Q, I can directly figure out sine R and cos R. So I hope this question is clear. So that's the second aspect in trigonometry that you need to understand, that sine and cosine of complementary angles are equal. Now moving forward, if you see this question, that's a pretty straightforward question. It says, as I already told you, sine 90 minus theta is equal to cos theta. So they are asking you in this given equation, k is a constant, which of the following could be the value of k? So if I compare the expression that I have written above, so sine k minus x is equal to cos x, that directly tells me that the value of k is nothing but 90 degrees. So from here, I got k as 90 degrees. But be careful again, they are not asking me the value of k in degrees. If I look at the options are in radians. So I have to convert this degree measure into radian, and I know the conversion 360 degree is equal to 2 pi radian. 1 degree will be equal to 2 pi by 360, and 90 degrees will be equal to 2 pi by 360 into 90. So 90 goes 4 times, 2 pi by 4, that will actually be pi by 2. So I converted the degree measure into radian and I'll mark option number C as my answer. That's pi by 2. So again, guys, this is important. You might get a question on this conversion, that sine theta is equal to cos 90 minus theta, cos theta is equal to sine 90 minus theta. Now moving on to the third aspect, guys. Moving on to the third aspect, which is actually the similarity of triangles that you need to understand in trigonometry. So let me just quickly draw two triangles and we'll try to understand the similarity of the triangles. So if I say there is one triangle ABC, is one triangle ABC. Let's say this is angle 1, so I'm giving them numbers. Let's say this is angle 2 and let's say this is angle 3. And if I take another triangle, let's say another triangle which has the variables or the vertex as PQR. So let's say this is P, this is Q, this is R. And if I say the angle measures are actually equal, let's say this is angle 1, this is angle 2, and this is angle 3. So I know all the three angles in the first triangle is actually equal to all the three angles in the other triangle. So I can say that both the triangles are similar. The point that you need to know in trigonometry is if two triangles are similar, the sine, cosine of the equal angles will be equal. So I can say sine of A is actually equal to sine of P, because both the angles are equal, so their sine will also be equal and their cosines will also be equal. So I can say cos of A will also be equal to cos of P. Similarly goes for the other angles also. So I could have said sine of B is equal to sine of Q and cos of B is equal to cos of Q. Similarly, I could have gone for the third angle. I could have said sine of C is equal to sine of R and cos of C is equal to cos of R. So the point that I can make here is that sine and cosine of equal angles are equal. So I can say sine and cosine of equal angles are equal. So this is the point that you need to understand while working on trigonometry. So if two triangles are similar, their sine and cosines of equal angles are equal. So let's try to apply this property in a question. So let's try to do a question. So here in this question, so there are two triangles. Triangle ABC is similar to triangle DEF. Okay, so let me try to draw the triangle where A is corresponding to D, B is corresponding to E, and C is corresponding to F. And be careful, they have already mentioned angle A as 90 degrees. So if I try to draw a triangle, let's try to draw. So guys, let's try to draw a right angle triangle. So let's say this is the triangle ABC. This is value A, this is B, and this is C. Similarly, if I try to draw corresponding triangle DEF, so there's another triangle which is actually similar to the first triangle, and it also tells me that A is corresponding to D. So that means, let's say this is D. B is corresponding to E. So let's say this is E. And C corresponds to F. Let's say this is F. So all these angles are equal actually. A is equal to D, B is equal to E, and C is equal to F. So this angle is also 90, and here this angle is also 90. Again. Now they have already given me cos of F. So they have given me cos of F is equal to 0.81. and I need sine of B. So guys, if I already know cos of F, so can I say that cosine of this angle will always be equal to cosine of angle C? Because if two angles are equal, their cosines will be same. Now guys, if I say, let's say this angle is theta, so this angle has to be 90 minus theta. Now I know they are complementary angles, and I know that sines and cosines of complementary angles are equal. So can I say that cos of C is nothing but equal to sine of this angle, sine of this angle B? So I can directly say that cos of C is nothing but equal to sine of B. And eventually all these three values are equal, which is already given to me in the question, so 0.81. So you see, the answer was actually hidden in the question itself. So that's the point of similarity that you need to understand, that if two triangles are similar, the sines and cosines of equal angles are equal. So I can say that cos of F is actually equal to cos of C. And now when I get cos of C, I know that cos of C will always be equal to sine of B, because C and B are complementary angles. So sine of B will also be 0.81. So guys, I hope the three aspects are clear. The first aspect was conversion of radians to degree, degree to radian. The second aspect was that sine theta is equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. And the third aspect, which is drawn here, that similarity, that sine and cosine of equal angles are equal. So basically these are the three facts that you should know, and if you know these three facts, the questions are sorted in your trigonometry. So guys, I hope the concept is clear. Thank you for watching the video, guys. Thanks from my side. Bye bye.